This presentation is about free and open source software. Hi everyone, my name is Greg Hislop. I'm a professor here in the College of Computing and Informatics. I teach mostly courses in the software engineering area. I do also teach our senior design project. So no matter what major you're in, you might have me for senior design project because it's taken by students in different majors. That is a 3-course sequence that you take as a senior. It's intended to be a capstone design experience where you get to apply things that you've learned during all your years here at Drexel by working in a team and conducting some sort of a project, a research project or construction of an open source software system or software system, and so on. So today we're going to talk about free and open source software. That's sometimes referred to using the acronym FOSS, and that's pronounced FOSS. So you'll find as I go through the presentation, sometimes I'll say open source, and sometimes I'll say FOSS, and I'll be using those terms interchangeably. I mean the same thing, no matter which one I happen to use. So we'll start off by talking about the background of open source, how it came to be, what exactly it is, why does it exist today, how does it work, how is it that we have all this software that's been created that you can get access to and look at the source code and use for free. And we'll also talk about the importance of open source today and in the years where you'll be out working as a computing professional in one area or another. And we'll talk about how all that open source software gets created. How can it be that there's software that's available for free when other software you have to pay for in order to get? So why are we doing this in CI 103? Why is this one of our topics in CI 103? Mostly in this term, you're spending a lot of time working on a team project and getting some first experience to working in a team to try and do something, some sort of a project related to computing. But along the way, while you're doing those projects, we also have a series of presentations that we do that are intended to help you understand computing a little more broadly, to help you see different aspects of computing and see some of the larger context in which computing fits. And open source, this presentation on open source is a presentation that we do with that sort of background in mind. You'll have others during the term. I know you have one scheduled on data privacy and what the responsibilities are of a software developer to ensure data privacy. We'll have somebody come and talk to you about entrepreneurship, which is often a feature in people's careers in computing. So all these different lectures just help to give you some foundation concepts and understanding of what our college is about, computing and informatics, and what the major that you're headed into is about as well. So that's how open source fits into the picture of your course this term. Now, why should you be interested in FOSS and be interested in studying that? One of the things you have to understand is open source is actually a very substantial segment of the entire IT industry. No matter what you do in computing, or even if you don't work as a computing professional, you will use open source products. You may have already downloaded some product that you understood to be open source and be using that as a part of the way you do computing. Even if you haven't done that, every time you use the web, you are dependent on open source software. Many of the key software components that provide the infrastructure of the World Wide Web are actually open source products. And you use those every time you touch the web. You're taking advantage of that infrastructure, including many components, key components of the web that are open source. You may also find over time that you end up working on an open source project. You might do that as a contribution that you make without being paid for it. It also can be that you work on an open source project and somebody pays you to do that. And I'll talk about how that could possibly be, why somebody would pay you for a software product that is available for free, pay you to work on it. So you might also be part of an organization. Any large organization today has to figure out how their products and their software work relates with the world of open source. People use open source as part of other products. They use it in their commercial endeavors. And you need to understand open source to know how all those pieces can possibly fit together in a company that you might work for or a government agency that you might work for. There's another reason why open source is important for you as a student, and that is that it provides an unparalleled opportunity to learn about software and to learn about computing. It turns out that open source teams, the people that develop open source software, tend to be very advanced in their use of software engineering. So they are typically globally distributed software product teams that are very adept at working with each other remotely. Remote work has become much more common in commercial software, proprietary software, as well as open source in recent years. But the open source world was really where the pioneering work was done to figure out how to allow people on a team to work with each other when they might never be in the same place physically. Open source, from a software engineering perspective, also tends to embody a lot of innovative use of tools and techniques for doing software engineering. In fact, if you look over the last 10 or 15 years in particular, most of the really interesting developments in software engineering have come out of the open source world and been adopted by proprietary or commercial software developers. So there's an awful lot of innovation in software engineering that happens in open source. And that's one of the reasons why it's so interesting for you to know about as a student. Also, because open source involves an open environment, you not only can see the software code itself, the source code, but you can also watch how an open source project operates. Open source projects tend to publish all their planning documents. You can see their defects. You can look at their defect databases. You can see what sort of problems they have and what they're trying to hit. You can look at their planning for the next release. All these sorts of processes and documents and tools that they use, you can observe up close and learn how a large open source project or how any large software project actually works. If it's a proprietary project, you don't have access to all that information and data and documentation and source code. So open source just provides a great opportunity for you to learn. If you want to learn about how software engineering is actually done on a large scale, or if you want to learn about particular technologies, you can find examples of many programs, large software code bases written in almost any language you can think of. So very, very wonderful learning opportunities, which gives a whole nother reason for why you should be interested in studying open source as you go along through your education and even after you get out and you're working as a software or other computing professional. So let's talk about where this all came from. What is the history of open source? So we'll tell the story here now. Once upon a time, here's where open source came from. And we have to go all the way back to the beginning of the computing industry in order to do that. This is hard to believe if your perspective is computing today, but if you look at the roots of computing, when computing first started, computing was a hardware business, period. That's all it was. Software was something that was created, that was invented in order to make the hardware work better and allow the hardware to be more flexible and to do more things. But software was not a product in its own right. Nobody thought of software as a product. It was just something that was needed in order to make the hardware work. So all the companies that were in the computing business originally were hardware companies. They didn't even think about software. They didn't think of it as a product. They just bundled it in with the hardware. It didn't have a separate price. In order to use the hardware, you needed the software. So when you paid for the hardware, you got the software. Now, in those days, computers were much less reliable. People were still trying to figure out how to do computing, how to write programs, how to write software. So very often when somebody bought an early computer, they got the source code for the software and not just the compiled version of the software. And in addition, people who used a given computer would exchange software among themselves for free. They would say, hey, we came up with this really great way to use this computer. You're using that computer too. Here, we'll give you a copy and you can use it. And there was a lot of exchange, which helped promote exchange of ideas. Right? But everybody was always thought from a product point of view, everybody only thought about the hardware itself. So at first, software was shared. The early approach meant that there was a lot of exchange of ideas, right? People were passing programs around, they were passing around software. But by passing around the software, they were also propagating ideas, which created opportunities for people to learn. You have to remember in the early days, there were no software engineers, there were no programmers, there were no software developers. You had people who were working with the hardware, and they had invented this thing, software, as a way to make the hardware more valuable and more flexible. Nobody knew how to write a program. So in the early days, people were trying to understand, how do you do this? How do you write programs? And this exchange of software in source form allowed people to exchange ideas. It's also important to understand that in these days, the computing industry was much, much smaller than it is today. There were not computers everywhere you looked. There were not computers in every home. There were a relatively small number of computers. Many of the computing activities that were taking place were connected initially to universities. And universities over the early decades of computing were key players in the computing industry in a way that they aren't today. There were very close contacts between the computing hardware companies and the universities to try and develop this new industry, this new area of electronic digital computers, as they were referred to in those days. So the whole computing industry was new and small and much closer to the research roots, which involved both people in the hardware companies and people in universities. So they were in the habit of passing software around. If a hardware company came up with a new operating system for a computer, they would often make that available to universities in source code form so that they could share and talk about and do research on how to write software. So it was a very different kind of an industry and very different world in terms of the level of sharing. Now, over time, commercial organizations in particular started to buy computers and started to use computers to do various kinds of processing that were closely integrated with their business. And as the industry grew, as it started to be a significant amount of economic activity during the 60s and the 1970s, you started to see that companies would start to develop custom systems for individual customers. So a large corporation might hire software people at their hardware supplier to write a custom system for them. And over time, what happened was this developed into an independent software industry. People who had been software developers for a hardware company would leave the company, set up a little company on their own, and start to write software for the customers of the hardware vendor that they had worked for previously. This was a completely new idea, this whole notion of an independent software vendor. Independent just means they weren't part of the hardware company, the company that supplied the hardware. They were separate from that, but writing software for that hardware. The whole notion of an independent software vendor was completely radical in the early days in which these little companies started to be created. And in fact, there were lawsuits. Some of the hardware companies sued the first software companies and said, hey, you can't write software for this. That's our hardware. We own it. And they felt like they should own the software that ran on the hardware as well as the hardware itself. Those suits, fortunately, we wouldn't be where we are today. Those suits, the hardware vendors were told they couldn't do that the software vendors could write software for their hardware. And that's how the independent software vendors, as they were called in the early days, came to exist. They actually had to survive legal challenges in order to exist. So what happened, another way to think about this, is software became a product. And all of a sudden, people started to think about software as having its own value, separate from the hardware. Now, once that happened, the hardware companies, which had been very free about circulating their software to anybody who had their hardware, started to think about the software in this new light. They started to think about their software as a product. And they started to think about software as intellectual property and as therefore something that they needed to protect. So the legal people at the corporations, the hardware companies, got involved with software and starting to think about it as intellectual property and to think about how can we protect our intellectual property, how can we use it to our advantage competitively. And as that evolved, access to the source code disappeared. And when somebody bought the hardware, they got the software to run the hardware, but they didn't get it in source code form anymore. They only got it in compiled form, the .exe in today's terms. Well, if you only have the .exe, you can't study the software anymore. You can't really see what the statements are that were written in order to create that software. And that was exactly the intent. They didn't want other people to understand what their program looked like. They just wanted to understand it as if it was a black box. They could see what the features were, what it did, but they didn't have easy access to understanding how the program was actually written before it was compiled into an executable form. So as all that evolved, there was some reaction to that and some pushback, primarily from several different universities. I'm going to talk about the key one here, and because this was really the roots, the initial concept of what we think of today as free and open source software, FOSS. There was a person up at MIT, a guy named Richard Stallman, who was associated with one of the early MIT artificial intelligence labs, and he had been part of those early days of software, where software was freely exchanged among universities, and people passed around copies of the source code of programs, and everybody could see the source code of the programs that came with the hardware, the operating system, for instance, that came with the hardware. And he had been part of this tradition of sharing source code and had benefited from the fact that people were learning from each other and there was a lot of exchange of ideas. And then he was part of this phase where all of a sudden software became proprietary, source code got locked up, and the people in the universities lost access to the source code and they lost the ability to freely exchange source code programs as they had in the past. And he recognized that that was really a big loss from an intellectual perspective, that it denied people an opportunity to learn and be able to study existing software in the way that they had been able to do that before. So around 1984, he founded a project called Project GNU. Project GNU still exists today. It's still an active project. And we'll talk a little bit about where it is today. You all have probably seen some bits of Project GNU and not even known it. Right? But his goal was to create an entire software platform, operating system, and all the programs you need to go with an operating system that would be open, would be free for anybody, free in terms of not costing anything for them to get it, and free in the sense that they could see the source code, they could modify the source code, they could pass it on to somebody else beyond that, and so on. So his idea was to create this GNU operating system and make that the foundation for a complete environment of free software. And he set out on that quest to do that. Over time, this evolved and different things happened. One of the things that he did was create an organization called the Free Software Foundation, or FSF, which still exists today. And they started to work on this Project GNU. But at the same time, they also started to work on the legal question of how do you actually create free software? And they really had two things in mind by using that term free software. They did mean that, yes, you could get it without charge. They were going to give this away to people. But what they really meant more was that they wanted it to be unrestrained. The use of it was unrestrained, that people were free, as in freedom, free to do anything they wanted with the software. Including changing it, modifying it, passing it on to other people, and so on. There were some restrictions. You had to leave an indication on there as to where the software came from. That, for instance, if it was Project GNU, you had to leave a note on the software that said, this is part of Project GNU, and I've modified it, and here, now you can use it. Right? So they started this out, and they worked out a legal way, legal mechanisms for doing this. And I'll talk about those legal mechanisms in just a minute. If you want to read the way they tried to define this notion of free software, there's a link here. GNU.org is the Project GNU. And they've got some information about free software and what they mean by free software. You can also go to the Free Software Foundation. If you go and Google Free Software Foundation, you'll find they have lots. They're a very active foundation even today, and they have a lot written about free software and how it works and why it exists and why they think it's important and so on. So there's a lot you can follow up with there if you're interested. Now, the GNU operating system is probably one you haven't heard of. Right? You're probably familiar with Apple's iOS, or you're familiar with Microsoft Windows. Those are the dominant proprietary operating systems. You may also have some familiarity with Linux. Maybe you've used that, or maybe you just heard about it. But it turns out that Linux is actually the operating system which is where you use Project GNU. The GNU operating system has yet to be successful. It may be someday, but it seems unlikely at this point. Has yet to be successful as an operating system. You don't hear people talking about the GNU operating system. But what happened instead was, along the way, a lot of an operating system had been created via this Project GNU. And somebody came along, a guy named Linus Torvalds, and he said, hey, I want to write an operating system kernel, which is kind of the core part of an operating system. And he wrote an operating system kernel called Linux and combined that with a lot of software from Project GNU. And those two together are what we now refer to as the Linux operating system. Much of the software in the Linux operating system actually comes from Project GNU. And that was combined with the Linux kernel. And those two together are what people colloquially refer to as Linux. It would more correctly be called GNU/Linux. That would actually be an accurate name for what everybody uses. That's unlikely to happen at this point. Everybody knows Linux as the term. But in fact, GNU Linux is what you're really using when you use what we call the Linux operating system. So what is this free software definition? There are a lot of different ways that this has been stated. My first bullet point here shows a sort of a summary definition. Free software is about a user's freedom to run, copy, distribute, study, change, and improve the software that they use. So that gets broken down into what are sometimes referred to as the 4 freedoms. That you have the freedom to run the program for any purpose. You have the freedom to study how the program works and change it. The freedom to redistribute copies, and the freedom to distribute copies that you have changed. So you make modifications and you distribute the software with your modifications as part of the software. So those are the 4 basic freedoms. Those in practicality unfold in the way that people talk about or think about open software. If you know about open source software, what you probably know is I can get it for free. You can download it without having to pay anything. That is generally true of open source software. The other part is that I can see the source code of the software. Right? And those are really practicalities that underlie this. In order to study how the program works, you have to have you have to have access to the source code. In order to be able, if you're able to redistribute copies, then you really can't put a price on the software. It can't be proprietary software and priced the way proprietary software is, because one person could buy it and then they could just give it away to everybody else because you're allowed to redistribute it freely. So practically speaking, open source software is available without charge, and it's available with the source code. Right? But really what free software is about is summarized in these purposes that are a little more abstract, but really important concepts for how free software or open source software works. Now, how do you do this legally? How do you implement free software? If you really want software to be free and stay free, the people who at the Free Software Foundation wanted to be able to write software, make it available freely to people, but then have it stay free as it passed from person to person to person, free in the multiple senses that we just described. Now, in general, if you looked at software at the time that the free software movement was being born, you could lump everything into 2 different categories. There's what's called proprietary software or commercial software. That would include things like Microsoft Windows or Microsoft Office, many of the software products that we use today. Right? In that case, the software is licensed, but the license is designed to restrict what the user can do with the software. If you buy a copy of Microsoft Office, they have a thing called the End User License Agreement, or EULA, E-U-L-A. And what that mostly does is talk about the fact that the software belongs to Microsoft, the software continues to belong to Microsoft, all the rights related to the software are maintained by Microsoft, except what you have bought is the right to have one compiled copy of the software and use that copy on one computer. That's what the typical EULA says. And all other rights you do not have. You don't get access to the source code. You can't sell it to somebody else. You can't give it away for free to lots of people. None of those things can you do. That's this typical proprietary license, right? The whole idea of the license is to lock the intellectual property and reserve it to the software vendor. There's another possibility, and that is there are intellectual property items. This could be a book, but it could also be software, which are what is known as being in the public domain. If something, a program, let's say, that you write is in the public domain, what that means essentially is that you have given up all your rights to it. You have no control whatsoever. So it's just available. Let's say you post it on the internet and you say it's public domain. That means you have no right to it at all. Anybody that wants to can pick it up, they can modify it, they can slap a different name on it, and they could make it a proprietary software product and start to sell it. There's nothing that keeps them from doing that. Or they could give it away if they wanted to and keep it as public domain. It's completely up to whoever has their hands on a copy of the software. So when you put something in public domain, you give up all your rights. So neither one of those was really what the people that started free software wanted to do. So they came up with a novel idea. And they said, okay, here's what we're going to do. And there were some legal people that were involved in working out these mechanisms. Here's what we're going to do. In order for something to be free software or open source software, there are actually two things that have to happen. The first is you have to copyright it. Right? That copyright is a legal mechanism that takes intellectual property rights and it reserves the rights to the person who created the material. It's used for books and it's also used for software. So it's a legal mechanism for holding the intellectual property rights to a piece of software. So the idea with open source is to say we're going to copyright it, which means we're going to claim our rights as the creators of the software. But then we're going to combine that copyright with a license, just like a proprietary software vendor does. But this license will be very different because instead of the license stating that all the rights or almost all the rights stay with the creator, what we're going to do is we're going to create a license that gives away most of the rights to other people that want to use the program. So the whole idea of an open source license is to share the rights with other people, but not allow them to do things that we don't want to do, like make the software proprietary. So what it does is it creates a legal framework that makes it clear who owns the software, but that gives away a lot of the rights so other people can use it freely without paying for it, that they can have access to the source code, and that it can be redistributed to other people. But if it's redistributed, those same rights have to go with the redistributed versions. You have to acknowledge where the software came from, who actually owns the software, who has the copyright, and you have to continue to extend the same rights. Like you have to share the source code with future users that you might distribute the program to. So this combination of copyright plus a special kind of license, an open source license, is the way open source works. That's the legal mechanism that was created in order to allow for open source software. This combination of copyright plus an open source license is sometimes referred to as sort of a tongue-in-cheek term, is sometimes referred to as a copyleft license. It's the use of copyright plus an open source license in order to guarantee that software can be distributed, modified, studied, so people can have all those four freedoms that we talked about on a prior slide. The granddaddy license for open source for copyleft is something called the GNU General Public License, sometimes referred to as the GNU GPL. That is the prototypical open source license, and it's still very widely used today. So if you look at a piece of software, here's a very practical tip for you. If you're looking at a piece of software somewhere out on the web and you want to know, could I pick this up and use this in a product I'm trying to build? You got to know what to look for. If it doesn't have anything on it, no indication of licensing or copyright, you can't assume it's public domain. You have to assume it's copyrighted and somebody else owns it. And you don't have any right to it or any predictable right to it. In order for something to be established as open source, you should expect to see a copyright statement and you should expect to see a license, in particular an open source license that gives you the rights to go and use the software in ways that you might want to, or to study it, or to incorporate it with other code. Now all of this developed, Project GNU started to unfold and a lot of people started to contribute to it. The legal framework was created on how to allow software to be open source, and a lot of open source products started to appear, free software products started to appear. And as this expanded, businesses got interested in open source. But there was a bit of a problem, and that is the Free Software Foundation and their strategies for doing free software sometimes seem to be anti-business or anti-capitalist. And so corporations were looking at open source and they were interested in it, but they weren't really comfortable with it. So there was another group that sprang up that created something called the Open Source Initiative. And this is really where the term open source came into being. Earlier on, the Free Software Foundation wanted to use the term free software. And you'll find that they still use that term today. They don't like the term open source. So the acronym that I used at the beginning of this talk, FOSS, free and open source software, is an acronym that people use to try and be neutral between these two camps, the free software perspective and the open source perspective. Now, understanding the difference between those two is important. It's beyond the scope of what we can get into in this introductory presentation. But what I'll ask you to take away is just know that there are two schools of thought on what we refer to generally as open source software. There's the free software group and there's the open source initiative group, and they have slightly different perspectives. Now, as a student, a lot of this won't matter particularly because in each case you can get a hold of software without paying for it legally. You can use it without paying for it, and you can also get a hold of the source code. The differences come into issues that extend beyond that. As a professional, you may find that it's important for you to learn what are the differences between open source and the Open Source Initiative and free software and the Free Software Foundation. But for today, just know that there is some difference. But if you want to get a hold of the product and use it, you want to be able to get a hold of it without paying for it, use it legally, you want to be able to see the source code. Either of these approaches, the Open Source Initiative or the Free Software Foundation, will get you that much. Okay, so slightly different principles, mostly related to combining free software or open source software with proprietary software. Different emphasis on why we're doing what we're doing that has to do with leveraging peer development and sharing software across organizations. Right? But that's something for you to read into a little later on if you'd like to. So that's how we got to where we are today. There's these deep roots that go back to the 1980s with the emergence of free software, and then later than that, the emergence of this notion of open source software. Nowadays, in general conversation, people just tend to lump them all together and refer to it as open source. But in fact, there are some differences depending on which, and mostly it'll play out depending on whether you use a license, which is a free software license, or a license which is an open source software license only. So where are we today? All right, all of this effort has happened, all of this thought and careful work about legal structures. A lot of software technical work has happened over the years. I've already mentioned Linux. Linux is an open source or a FOSS product. That certainly has been important in the software industry. But in fact, there's a lot more that's happened in open source, and you may only have brushed against it in one or two areas. You may not understand just how much open source software there is and how important it is to the computing industry overall. So that's what we're going to talk about in the second part of this talk. Let's start by just thinking about some products. I've got a couple of slides here that line up a proprietary product and an open source product. And in each case, there are parallel products. So how can that be? You know, let me just talk about a few of these. Many of you are familiar with Microsoft Office. And the fact that that provides Microsoft Word and the Excel spreadsheets and so on. There are open source equivalents to those products. So there's a whole set of products called OpenOffice. There's another corresponding set of products called LibreOffice, which if you go and look at them, you'll find there are analogous projects for word processing, for spreadsheets, for presentations, and so on. So you can either get a product you pay for from Microsoft, or you can get a product for free from OpenOffice or LibreOffice. Similarly, if you want to set up a web server, there are web servers that are open source. Apache is one of those, a widely used web server. IIS is a proprietary web server that's provided by Microsoft. For operating systems, I show here Microsoft Windows, which is a proprietary product. And we show Linux, which we've already talked about, which is an open source operating system. So in each case, you have these parallel products, one of which is open source and you can get it for free, and the other of which is a proprietary product that you have to pay for and for which you cannot get the source code. So how can that be? Turns out there are trade-offs between these two, and there are histories between these. In some cases, the open source product is actually the market leading product. Almost any survey you see about web servers around the world will show Apache as being the dominant web server, the #1 in terms of market share, and IIS and other proprietary web servers as having smaller market shares. On the other hand, Microsoft Office is a very strong product suite, and I've never seen anything that would indicate it doesn't hold the leading market share for Office product suites, PowerPoint and Word and Excel. LibreOffice is a very credible product, but if you use it, you'll tend to find it's not as sophisticated as Microsoft Office. So the point isn't that the proprietary products are always better or that the open source products are always better. There are cases of both that I think you could argue the proprietary product is better, or you could argue that the open source product is better or has more market share. But the point is that in each of these areas, there are both proprietary products and open source products that have significant market share. If you look at the top 5 products in given areas, you will often find a couple of proprietary products and a couple of open source products that are coexisting in that particular market niche. Same thing if you look beyond that. This next slide, I show some other product slides. You know, in the web browser area, you have Mozilla Firefox, and you have Microsoft Edge now, which was Internet Explorer before, but has been replaced by Microsoft Edge. Both cases, you've got products that have strong market share. You also have products that are a little more complicated. At the moment, Google's Chrome seems to be the leading market share browser. Chrome has proprietary parts, but the heart of Chrome is built on a project called Chromium, which is an open source web browser. So the open source web browser is the core of a proprietary browser that has proprietary elements, Chrome. And so there's a mix there of proprietary software and open source software. Android and iOS are the 2 of the common operating systems in cell phones. Android, again, the core of Android is an open source project. It's by far and away the dominant cell phone operating system. iOS, on the other hand, is a very highly thought of, much smaller market share, but very well thought of cell phone operating system. It's proprietary. R is a project for statistical analysis, for doing analysis on data. It's very, very popular in data science circles. So if you've heard about data science or big data or data analytics, R is a very, very important product in that niche. It's open source. There are other statistical analysis packages, SPSS being one example of that. SPSS has been around for decades. It started out in the eras of mainframe computers and has migrated to our current era of computing. And very popular, very well received, but it's a proprietary product. If you talk to people in data science or data analytics, you will often find that they're much more involved with R than they are with some of the older projects, or products rather, like SPSS. One final area, GIMP, is an image manipulation project. It comes out of Project GNU. It stands for GNU Image Manipulation Project. That's what GIMP stands for. It's open source. It is an alternative to open source, or not open source, proprietary products like Adobe's Photoshop, which is very well thought of, very well respected, but proprietary as a product. There are many tasks that you might do if you want to work on a photo, for instance, do some combination of photos or remove something from a photo that you don't want in the picture. You can do a lot of those tasks with either one of these products, but one of them is open source and the other one is proprietary. So in area after area after area, if you look at software products, you're going to find that there are open source projects and open source alternatives to proprietary products. If you're looking at a proprietary product sometime, go to the web and type in alternative to, or open source alternative to, and name the project. And you'll actually find that there are sites out there that try and identify open source alternatives, things that are available for free or where you can study the code, if you want to look at the source code, to proprietary products. That's how important the open source world has become. So how big is it? There's all sorts of measures. It's very hard to get a handle on how big open source is, but suffice it to say, there's absolutely no question that there are hundreds of thousands of open source projects that have produced products that are available to use, production versions of projects that are available to use today. Open source projects tend to live on hosting sites, which are sometimes referred to as forges. One of the older ones of those is a thing called SourceForge. There was a time where SourceForge was the dominant and most popular place to host an open source project. And there are still very successful, very well known open source projects that are hosted on SourceForge. They have something shy of 500,000 projects. That's a lot of projects. At the same time, over the last 10 years, let's say, there are some other open source hosting sites, GitHub being the one that's most popular now. GitHub has just blown up, incredibly large. Their most recent report, they do an annual report where they talk about how big GitHub is and how many users they have and how many downloads there are and how many developers are engaged in GitHub. In their most recent report like that, they reported that they now have 100 million repositories. Now, not all of those are open source projects, but there are millions of open source projects contained within that number. That's an astounding figure, that this much work is being done and being released as open source. People have tried to do estimates of number of people that are engaged in open source. One estimate, a study that was done, they came up with the notion that there were 800,000 developers working on open source. Now, as I'll discuss in a minute, one of the important things to understand is many of those people today are being paid to work on open source projects. There are entire companies whose business relates to open source. Probably the most successful of those is a company called Red Hat. Red Hat started out with a business distributing Linux. Linux is an open source operating system. You can get it for free. But they took on the job of packaging it, making, in those days it was CDs, making CDs with Linux distributions on it, making sure that everything that was on that CD worked well in combination with the other pieces that were on that CD. And they started to sell those CDs to corporations who wanted to have somebody put together a distribution of Linux related software. So it wasn't that the software had any price associated with it. Red Hat started their business by being the ones who ensured that the packaging, the combination of all the products that were on that CD and the different versions of those products were compatible with each other. That's really what they did at first. They weren't really selling the software. I mean, nominally, somebody was paying to get a CD with the software on it. But what they really were buying was Red Hat's service in putting together the right pieces of software to have in that system and the right versions of those software pieces so that they would play nicely with each other. That's how Red Hat got started. It grew to the point where it had over $2 billion in annual revenue. And then last year it got bought by IBM, one of the largest software company acquisitions ever. That's how much it was valued by that time. But think about that. Even at the time when Red Hat was purchased by IBM, all of their products, all of the software that they provided to their customers was open source. You could get it for free. So they're a software company in a way, but they weren't really a software company in the sense that they were selling proprietary software products. What they were selling was services around those software products. They were guaranteeing that they were keeping track of security vulnerabilities in the software. They were keeping track of which versions of which products were compatible with which other versions of different products. They were selling customization services related to open source products. They were selling training and consulting related to open source projects. And they built that into around 2.3 billion, I think they were, in the last quarter before they became a part of IBM. And they're still growing now as a part of IBM. They're now an IBM unit, but they still exist as a fairly discrete unit of IBM and still growing, all built around open source. So clearly there's a lot to this that has become a big business. And that's why it's so important that you have some understanding of it as a student. Now, it's also important to understand that just like in proprietary software world, open source is entrepreneurial. We have these millions and millions of repositories out on GitHub. Right? Most of those are projects that are never going to go anywhere. Just like we have many proprietary software products, software companies start up every year. We've got lots and lots of little startups. Out in Silicon Valley, they're famous for being in garages and places, little one-room offices. And that's true all over. There are companies like that here in Philadelphia. We have incubator spaces. Right in 3675, there are software companies that are trying to get started. 3675 Market, where CCI is. and other parts of Philadelphia. There are spaces where companies are trying to get started. Most of those companies never go anywhere. They're not successful at making a dent in the market. And the same thing is true in open source. Most open source projects that get started never attract a lot of users. They never attract a lot of developers. There have been studies done across thousands and thousands of open source projects. And what you find is that the average number of developers per project is 1. It's actually like 1.2 or something. Right? There are a small number of open source projects that have many contributors. A project like the Linux kernel has thousands of contributors. A project like some of these web browsers, some of the other products, LibreOffice, some of these other products I had on the slides, just a few slides back, have dozens to hundreds, and in some cases thousands, a few cases, thousands of contributors. And they have thousands, and in some cases hundreds of thousands or even millions of people who are using that software. Right? But most projects, that's not the case. Only a small percentage of projects thrive, but it doesn't matter if you have enough projects. Think about that 100 million repositories on GitHub, or even the 430,000 on SourceForge. If you have even a fraction of a percent that becomes successful, that's still thousands of software projects that have become successful as open source projects. So that's the world. You know, it's no different with proprietary startups or open source startups. Most of them don't survive, but there's so much going on that we get lots of good products in the end. So why do people do this? You may wonder, wait, this is open source. And the original vision of open source and the original way that open source worked, and especially in the free software world, was people worked on open source in their spare time, as a hobby, as something they did on the side. And there are many reasons why people still do that. People still contribute to open source projects just for free, just for fun. And people have done studies, shown on some of the results of one of those on this slide, of why do you contribute to an open source project if you're not paid for it and the software is given away for free? And there are a bunch of reasons for that. You can read through these yourself. A lot of times, and this is a key reason why many software professionals contribute to open source, they do it in order to learn new skills. You know, oh, I want to learn PHP. Well, there's a lot of open source projects that are written in PHP. You can go and study that code and start to contribute to the project. You'll learn a whole lot about PHP in a hurry. All right, I want to learn about, you know, a particular framework that's used with the language, or I want to learn about Python. I haven't had that yet, or Java. I haven't had that yet. Doesn't matter what it is. There's open source projects that use those technologies. And so a lot of times people will go to learn and develop new skills. Sometimes people just want to share. They want to work on a project that they think is doing something good. There's a whole world of humanitarian open source projects that I'm very interested in, where there are projects that are used for disaster management, for healthcare, for economic development, for education. And a lot of times people will contribute to those projects because they believe in what the project is trying to do. So anytime there's an emergency of any sort, a hurricane or what have you, there are software projects that are used to help in those areas, to do disaster relief. And some people really like that notion and try and get involved in these humanitarian open source projects. That area is sometimes referred to as HFOSS, humanitarian, free, and open source software, and happens to be a special interest of mine. So if that interests you and you want to talk about it, come and see me sometime. There are some people who just believe in the free software idea, and so they say software shouldn't be proprietary. I'm going to help with these projects that are trying to be open source, and so on. You can see some of these other ideas. Let me mention just one more. I want to participate in the FLOSS scene. There's another acronym, right? I've been using FOSS, free and open source software. People also use FLOSS, free and Libre open source software. They're trying to capture, Libre is a better term for what free software is all about. It captures the idea of freedom a little more distinctly. We don't have a good term in English to do that with, so people use Libre. And you will hear Libre software. LibreOffice is an office suite. You'll hear people in Europe especially talk about Libre software instead of free software. These are all different reasons that people contribute to open source, but it's also true that more and more, an awful lot of contributors to open source software are not doing it for free. They're not doing it out of the goodness of their heart, or they're not doing it because they want to learn something. They're doing it because it's part of their job. One survey that was done indicated that 40 to 50% of all the contributions made to major open source projects were made by paid employees, people who are paid to contribute to the project. This study is a number of years old now. I haven't seen a newer one, but I would be willing to bet that the numbers are actually higher now. There are a lot of people in major technology companies and other kinds of companies that actually have as a part or all of their job to work on open source projects. And you'll find different reasons for this, but there's a growing number of people who work in open source for their career. So I'll give you just a few examples of reasons why people do this as a business case. For a long time, IBM was a supporter of Linux. And you might wonder why. They were paying people to work on a free operating system. Generally, it's understood that the reason they did that was that it gave IBM, which is dominantly a hardware company, gave them an alternative to the Microsoft operating systems like Windows, that they wanted their own server level operating system. And Linux was there, so they opted to throw in with the open source movement and pay people to work on Linux. There's other examples too. If you look at large open source products that have lots and lots of users. So there are open source products for building web systems. There are open source products for content management. And companies try and use those open source products. And once that happens, you have an open source product and you have companies, commercial companies trying to use that open source product. That creates an opportunity for people to provide services around that open source product. So what you often see is that there are little clusters of companies around popular open source applications that provide services, commercial services, related to that open source product. And if you're going to do that, if you're going to provide services for the product, it makes sense for you to use some of your time to actually help contribute to the product. It helps you to know the product better. It helps you to ensure that the product, which you're dependent on for some of your revenue because you're providing services, that product stays healthy. It helps you to help steer the direction of the product for the future. So the product can go in a direction you think will be useful for the services you're trying to provide to people who use that product. So there are other versions as well. I already talked about Red Hat and the way Red Hat works. Red Hat contributes to the open source products that they use and provide services for. So lots of different ways that people justify why they might contribute to open source. So that's the end of our introduction. Let me just wrap up with a few thoughts for you. Now that you know a little bit more about open source, don't be afraid to grab an open source product and use it. You know, if you don't have access to Adobe for image manipulation, you can go ahead and grab GIMP and download it. It's free. That's not illegal to do. That's what it's intended for. You have to understand the license, but a product like GIMP is one that you can use. If you have a computer and you don't have another license for Microsoft Office, you can always download LibreOffice and use that on that particular machine. You can run Linux on a machine if you want to do that. All of those things are available without charge. You can go and study the source code if you want to do that from a student point of view, but from a usage perspective, you can just use them. And unlike getting a bootleg copy of a proprietary product, it's free, you know, and legal for you to do that. So I strongly encourage you when you can to use open source alternatives if you haven't got access to a proprietary product. You can also, your students, you can also use open source as a way to find code examples. You can use an open source project as a way to study advanced uses of languages you might be learning and so on. Over time, if you're a freshman and you're just starting with programming, you probably don't want to contribute yet to an open source project, although you probably can make a contribution sooner than you might expect. But you might want to look into open source projects that are looking for contributors, or humanitarian open source projects that would do some good, that would apply computing for some kind of social benefit. And there are lots of opportunities to do that as well. One other just small reminder, if you're interested in this area, I'll point out that we now have a course, Software Engineering 420, which is going to be offered for the first time. It's going to appear in the catalog starting in fall 2019. You can take that course as an upper level elective as a part of your degree program. We've offered open source software courses in various forms as special topics courses in the past. We have a graduate level course in open source software engineering, but now we're going to have an elective course in open source software engineering as well within our undergraduate programs. So that's the end of the presentation. I hope this has helped you to understand a little bit more about open source software and how that relates to you and why it's going to be an important part of your career, whether you work in proprietary software or not. It's not going to matter. If you're interested in any of these topics, you want to talk to me some more, There's down in the corner of this last slide or on the first slide, I have my email. Feel free to contact me. I'd be happy to talk to you about that. Also, as I mentioned earlier, I've spent a lot of time working on our curriculum. I spent quite a few years as an associate dean in the college, so I know a lot about all the different computing majors. If you still have questions about the major you're in, or if you're thinking about switching a major, or if you're interested in trying to figure out what careers your major is good for, I'd be happy to talk to you about any of those kind of topics as well. Talk to your advisor, that's important as well. But if you want to get into the details about the majors or courses you take or what careers that helps to line you up for, I'd be more than happy to talk to you about those things as well. So that's it for our presentation about open source. I hope you've enjoyed it, and I hope you will do something with open source as a part of your career here at Drexel.